In this video, I am going to teach you the basics of free body diagram, starting with weight, normal force and tension. How to label these forces in a given system. Let us first start with weight of an object. What do you understand by weight of an object? The weight of an object is the relation between the object and earth. There are attractive forces between the object and the earth. So practically this force is directed towards the center of the earth. But if you see relatively, the object is very small as compared to the size of the earth. So for any object lying on the surface of the earth, we will always label the weight as acting vertically downwards. Whenever you have to label weight in a free body diagram, you always label it as vertically downwards. Now, what about this system? A man is standing on a platform. So, in regular practical basis, we will say that this man is exerting his weight on the platform. But as we discussed earlier, the weight is the relation between the object and the earth. So for this man of mass small m standing on a platform of mass capital M, both of their weights will be acting vertically downwards. What exists between the man and the platform is a contact force whose magnitude is equal to the weight of the man. But you cannot call it as the weight. It is just a contact force whose magnitude is equal to the weight of the object. Next is normal force. What is normal force? It is a force which acts perpendicular to the surface in contact and it presses the body. We shall take some examples to understand how to label normal force. For a ladder inclined at a certain angle with the wall, the normal forces. Now how are we going to label it? Perpendicular to the surface in contact. So wherever there is contact, we will label it perpendicular. They press the body. Hence the normal force, let us label them as N1 and N2. Similarly for this system, a ball is stuck between a wedge. So at these points of contact, the normal forces will act perpendicular. Again, magnitude N1 and N2. Now, this system is a little bit different than previous systems. Here, this object is connected with a hinge. That means it will rotate about this point of contact. In that case, here we have a torque. So for a hinge, there will be two surfaces in contact and acting perpendicular. So the normal forces will also be perpendicular. Let us call them as Fx and Fy. And at this point of contact, the normal force will be perpendicular to the surface. Let us call it as N2. Try to solve this system by yourself. Label all the normal forces at different points of contacts between the objects. Solve it and you can post the answer on my Facebook page. The last thing we shall discuss is tension. It is a force that usually acts in ropes, chains, strings and threads. Some of the things that you need to remember about tension is that it always acts away from the body. Tension pulls but can't push. There will always be a pulling force wherever you label tension, and it is same throughout the rope or string for massless ropes. So for simplicity, when you consider that the ropes are massless, then it is same throughout the entire rope. We shall now discuss few examples on how to label tension in a given system for free body diagram. First one, For this given system, a mass is attached to a rigid support with the help of a string. We label the tension like this. Tension is pulling, so it pulls both the surfaces with equal force. Next one. These two blocks are connected with the help of a string through a pulley. Here we assume these pulleys are frictionless. Friction will be introduced later. And the upper block is being pulled away with the force F. Again, the forces will be exerted. Tension will be generated in the string. So, the pulling forces are generated like this and equal magnitude of tension capital T. Now, for this system, two masses are connected with the help of a string. So, here the tension will be generated in all parts of the string with equal magnitude of value capital T. Now, try to solve this system by yourself. Label the tension generated in different parts of the string and you can post your answer on my Facebook page. Find me on Facebook using my page Physics Tutorials and you can post your answers on the page. Or you can send your answer as a message directly to me. Also like the page for staying updated on certain videos and some quick hacks and funny memes. Also like this video, leave some comments and subscribe to my channel.